So good morning, everyone. My name is Carol Waters. I'm the County Director for Extension in West Potawatomi Extension Office in Council Bluffs area. And we want to thank you for coming to In the Field Friday. It's our first. And first up today is Sean Schaus. He's our Ag Engineering Specialist out of the Armstrong Farm area. So Sean, I will turn it over to you.
Very good. Thank you, Carol. And welcome everybody on this snowy morning in April. So we're going to start off this series with a topic that I thought maybe would be good for springtime here. Thought we should talk a little bit about soil erosion checkup on your farm or your acreage even. This is a good time of year to start watching for soil erosion and things that you could fix on the soil erosion front out there on your fields and properties. So we'll do just a basic here, and there won't be any big surprises in this, I don't think. You probably are aware of these things, but it's something that's easily overlooked. So if you've got fields where you see a lot of sheet and rill erosion like you see in this photo, you know there's a problem because you see the silt accumulating at the bottom of the hill like that. And we know pretty much what to do about that. A lot of times these are fixed, and I put fix in quotations there because we work around these types of erosion by just filling them in with tillage. They're shallow enough.
Share your screen, please.
That would help, wouldn't it? I got it ready to share, but try that again. All right. How's that, Carol? Is that better?
Perfect, thank you.
Yeah, sorry about that, folks. I was so anxious to go, I got going without actually sharing the screen. So with this kind of sheet and rill erosion, you can see what's happening, but it's shallow enough that you can just kind of smear over the top of it with tillage. And so frequently, that's what people will do, is kind of fix this with tillage. But if you're really trying to remedy this or reduce this in the future, stop it from happening so much year after year, we know that reducing the amount of tillage on those fields is going to help keeping more ground cover to prevent some of that raindrop impact that dislodges those soil particles and allows them to start moving down the hill is the way to go. And we've talked about this for years and years about increased soil cover and reducing soil erosion. We're even hearing more these days about things like cover crops. While they also provide some ground cover, they also help to build the soil health that kind of binds the soil particles together and makes them more resistant to moving when the raindrop impact and the water movement does come over the top. So that type of practices are going to make a huge difference on the sheet and rill erosion. But sometimes we have areas in the field where that same flow path happens time after time after time, and we get concentrated flow moving down through these areas, and they may be deep enough that it takes some serious tillage to fill them in year after year after year. And when you have a place like that, that's concentrated flow in the same place repeatedly, a lot of soil moves every time that shallow gully kind of empties itself out again. So for example, on this one, if this is say 300 feet down this hillside, and even if that channel that's being eroded there is only a foot wide and 6 inches deep, that's still 7.5 tons of soil every time that flow path cuts a new channel down through there. So you till it back in, next time it cuts out, there's another 7 tons of soil down to the bottom of the hill and possibly farther on down into a watershed someplace. So this kind of a place where you have to repeatedly till back in the same spot over and over again really needs to be treated differently. And I love the way they stated it in this Nebraska NRCS program. They said, fix it, don't disc it. So they're acknowledging that the way people usually take care of these is to disc them back in so they can cross them with equipment. But when you have to do that repeatedly, it's time to do something different. So let's talk a little bit about grassed waterways, which is the way we would typically fix this kind of a situation, is to make a flow path that's not going to erode every time water moves down through it. We see a lot of these grass waterways out on the landscape. They've been used for a long time and they're very effective, but sometimes people don't understand exactly what we're trying to accomplish here and how we need to maintain them. So let's talk a little bit about grassed waterways, what they're meant to do. The function that we want out of a grassed waterway is to carry the water safely off the field. So they're made to flow the water off the field. And in so doing, we want that waterway to prevent gully erosion as that water is moving down that flow path and off of the field. As opposed to some misconceptions, they're not meant to trap sediment. So this is not a filter. We're not trying to filter out and capture soil erosion that makes it to the waterway. We're not trying to filter that water. The water is not going to be cleaner at the bottom of the waterway than it is up at the top of the waterway. So it's not a sediment trap. It's not a filter. They're not even made to infiltrate the water. We're not trying to soak the water into the grassed waterway. We're trying just to use the grassed waterway as a protected flow path to get the water off the field without causing gully erosion. If you take a closer look at this one, this was taken the morning after a rainstorm, and you can see that right in the center of this grassed waterway, the grass is actually laid down. The water laid the grass flat, so the blades of grass actually are overlapping one another and making a really nice armored flow path that does a really good job of protecting the soil underneath. And this is what we want the waterways to do. We don't want necessarily stiff grass that's going to stay standing erect when the waterway is carrying water. We want it to lay down, let the water move off of there while protecting the soil that's underneath. So when grass waterways are designed, they are intentionally designed with a lower center portion to carry the water and sloped sides. It could be a trapezoidal cross section like the one on the left, or a parabolic rounded shape like the one on the right. But either way, they're designed with that lower center portion to carry the water, kind of making a grass armored stream to carry that water down the hill and out of the field. So what can go wrong with these? Grass waterways can fail in several ways. One is if the sediment coming off the field starts to fill in the grassed waterway. That can cause failure of the waterway. Or if you've got wheel tracks, ruts that run parallel to the waterway, or rows of crop even that are running parallel to the waterway, that can stop water from entering the waterway, so the water never gets into the grass waterway to flow. Or if you're not maintaining good grass cover in that waterway, if the grass gets killed out for some reason, then the soil is exposed again, you're not protecting it, and any of these things then can cause the water to flow parallel to the waterway or in the waterway on bare soil. That soil can erode and the waterway then has failed. And it's not hard to find examples of this. Just driving around any place you want in Iowa after some rain, you'll see waterways that have failed in one of these methods, where the water's flowing outside the waterway and eroding the soil, or maybe eroding down through the middle of the waterway, even though the waterway is still receiving the water. Unfortunately, when I went out to take this photo, I only had to drive 2 miles to find these 2 examples. So easy to find examples of failed waterways in Iowa. So what should we need to do? How do we maintain these waterways to keep them working properly? Number one, you just have to get out there and inspect them. It's easy to build the waterways and then kind of ignore them and assume that they're going to continue to work. I would say you want to inspect your waterways at least yearly, and preferably just go out after a heavy rain and take a look, because that's when it's easiest to see how the waterway was functioning and whether it's working right. We need to maintain that waterway shape. So it was designed initially with a certain depth and width to carry the water off of a certain sized field or watershed. We need that shape maintained. So if there are gullies that are starting to form just at the edge of the waterway or in the waterway, those need to be repaired so that the water can still get in there. If silt has started to fill in that channel in the waterway, that needs to be removed or regraded so that you maintain that depth and shape of the waterway channel. If there are trees or other obstructions in the waterway, those need to be removed so that the water can flow unobstructed down the waterway. If you think back to that photo I had of the waterway with the grass laid down flat, remember there were hay bales sitting in that waterway. And while it might be perfectly acceptable to occasionally mow and bale the grass off of that waterway, you certainly don't want to store the hay bales in the waterway. They become obstructions, and when the water has to flow around them, it's likely to start to erode the soil on that spot where it has to flow around that hay bale or other obstruction. You also need to make sure you keep a good grass cover in that waterway. So control trees and weeds so they don't overtake the grass in the waterway. And you may actually have to fertilize that grass occasionally, just like we would on a grass pasture or a lawn, to keep it in good condition. And then you want to make sure you control the field spraying that's happening for weed control. If you're using a grass herbicide, you don't want overspray from that to start to eat away at the edges of your waterway, or going completely across it to kill a strip through your waterway. So make sure that you can adequately control shut-off valves on sprayers so that you're not killing the grass in the waterways. You want to maintain a good, healthy stand in there. If you are mowing grassed waterways, you want to mow them before May 15th and after August 1st. You avoid the middle of the summer there because that's primary nesting season for a lot of the birds that we're trying to maintain in Iowa. So you want to avoid mowing during those primary nesting seasons. Other things to do on the maintenance: don't plant or till parallel to the waterway. This is probably the source of a lot of those cases where you see the gullies just on the outside of the waterway. People have planted up and down the hill parallel to the waterway, and that's just enough of a ridge and obstruction, the wheel tracks and the rows, that the water tends to flow then parallel to the waterway on the outside of it. So take those rows all the way up to the edge of the waterways so water flowing down the plant rows can get into the grassed waterway to flow on down the hill. Cross the waterways perpendicular to the waterways, so any wheel tracks that might become a flow path for water carry that water all the way into the waterway. If you're doing tillage, take that tillage right up to the edge of the waterway. Don't till parallel to the waterway, but you still want to maintain the width. Don't let that tillage keep eating away another 6 inches or a foot off the edge of the waterway every time you do it. You want to maintain that design width of the waterway. You want to limit traffic in the waterways. So when they're soft, you want to try to stay off of them so you're not tearing them up, causing ruts in them. And don't use the waterway as a driveway. That's just going to encourage a driving path where the grass might be killed out and that protection lost for that soil surface under the grass. And use appropriate outlet structures. We'll show a picture of those in a minute, but any place the grassed waterway empties into a lower flow path, like a road ditch or a small stream, you need some way to let the water fall down to that lower level. We call those outlet structures or grade control structures, grade stabilization structures. You need to maintain those. And then, of course, manage the erosion out in the field so there's less sediment coming to the waterway when the water flows off of the field. Here are a couple examples of those control structures at the end of a waterway. The one on the left, a nice one made out of concrete, really high quality durable control structure. On the right, you can't even see the structure because it's underneath the flowing water, but you can see how when the water falls there, it creates a lot of turbulence. That turbulence has energy in it and can start to erode the soil where it falls that distance, and that'll eat its way back up into the waterway over time if it's not armored and protected somehow. So for other equipment operators, other than the farmer, someone who's out there doing manure application, fertilizer application, spraying, those kinds of things, advice for those folks, stay off the waterways if they're too soft to support the vehicle traffic. Don't make ruts parallel to the waterway because that's going to encourage water flow outside the waterway that's going to erode the field right along the edge of the waterway. Cross those waterways on the contours so that any water that does follow your wheel tracks gets into the waterway to move off the field. And if you can't avoid that and ruts are made through the waterway, notify the owners so they know to go out and inspect it and do any necessary repair. You don't want to just leave that where it might cause problems down the road. One other thing then too is to remember, even though it may look like a waterway, if there's a channel in the bottom of it, a bed and banks and a flowing channel at the bottom, that would be considered a water course or water source, which is Iowa's legal terminology for a small stream. Why would that make a difference? Because there may be setback distances for things like manure application on the surface of the ground. There are distances they have to maintain away from water sources, but not from grassed waterways. So when an eroded channel gets going in the bottom of these waterways, the legal definition of that changes from a waterway to a water source or stream. So it's important to recognize that difference and keep that channel from forming in the bottom of the waterway if you want it to be considered just a grassed waterway. So in summary, you've got to remember that the waterways are there to safely carry the water off of the field and prevent gully erosion while that water is moving. And we just don't want to do anything that would impair the function that's intended for that grass waterway or pollute the water that's moving off the field by some problem in that grass waterway. And that, friends, is a quick and dirty summary of grass waterways and their function in helping us prevent that gully erosion in the fields. So with that, I'll stop and see what questions that might have raised.
Sean, this isn't a question from anyone online, but the one question we get the most at the extension office is, I need to fix my field. Is there any funding available?
Of course. Yes, and for some things there is. When you are making improvements to a field, if you were adding grass waterways, for example, to help control erosion in an area, then yes, there is funding help available for things like that. You would want to talk to the Natural Resources Conservation Service in your county about programs to support erosion control practices and other resource protection practices. When you have used that kind of financial assistance, you probably will have signed a maintenance agreement as part of that assistance. And so it may spell out very clearly for you what kinds of maintenance is expected of you over a period of years. And while you're under your maintenance agreement, you may not be getting any additional funding because you may have already received funding that was intended to give you incentive to maintain that practice. But it's always worth a call to the Natural Resources Conservation Office and talk to them about which programs they have that might be applicable to the kind of resource protection you're trying to do.
Perfect, thanks. Are there any other questions?
Yes. Can you hear me?
We can.
Okay. So I have two. The place where our waterways are is Prairie. There were waterways there that we couldn't put into CRP Prairie, so we're haying those. But what used to be farmed is Prairie. but we're noticing that along some of the places between the waterway and the prairie, is getting to be erosion. So it's, you know, like those beginnings of gullies that you were talking about. So do we just need to continually fill in those mini streams or whatever?
Yeah, I think initially, if it looks like the ground slope is still adequate to get the water off of the prairie grass and into the waterway, then just filling in that small gully that starts to form may be all that's necessary. If it happens repeatedly, though, then I think it might be worth having someone come out and do a good inspection of whether it needs to be regraded a little bit to help restore that slope to get the water into the grass waterway. It may be that there has been enough silt accumulation at the edge there before the permanent grass cover was established, that the shape just isn't quite right to get the water into the waterway. So if you see that repeating itself, recurring in that same spot, I think it might be worth having somebody check the slope of the ground there to see if a little bit more regrading is necessary rather than just filling in the small gully. They may actually have to kind of shave it down, reshape it a little bit to reestablish that slope to get the water into the waterway.
Okay, it's on a hill, but maybe the edge of the waterway might be a little high. How do you said that the waterways are pretty old. So how do you tell that is it visibly apparent that the middle is lower?
It should be, yeah. There should be enough depth to the waterway that when the grass is relatively short, you can see that lower elevation in the center of the waterway. If you were to stand in the center of the waterway, you should be able to tell that the edges are at least a foot or foot and a half higher than the center of that waterway. So if you kind of walk through that area, look at it, and you really can't see where the waterway center is, that's probably a good sign that over time it has filled in enough that there's not adequate shape there to get the water to the center portion.
Yeah, it may never have been, in quotes, waterway, because they've always called them grass strips, grass conservation strips.
Okay.
So it may never have been that shape. I don't know.
It's possible, yes, that there never was a constructed channel formed in that waterway. It may have flowed well enough in that spot and had a grass cover on it that they just left it alone rather than going in and grading a constructed grass waterway channel. So then it's back to, you kind of think about the function here. If the water is moving in a place where the grass cover isn't adequate to stop the erosion, then we want to do what we can to improve the situation. So it would be a matter of looking at it and saying, well, is the shape adequate to get the water to the best spot to flow down the hill, or do I need to reshape it? Or is it just a matter of it's flowing in an okay place, it's just that the grass cover there isn't the right density or the right species of grass to be able to armor that soil adequately when the water does flow there. So it could be just a little bit of change in the type of grass seeding in the place where the water does want to flow might be a good solution also. That's where it might be nice to have one of the experts, the folks who do the waterway design, take a look at it and see what they think would be the best solution for you.
Yeah, well, the main problem is where the prairie meets the grass. The grass is not eroding. It's
Okay.
where the prairie meets the grass. We get this run sideways.
Sure.
So I guess maybe that's where we need to make it a little higher and see if it sticks.
Okay, yep, I think a little reshaping there might be necessary then to get the water all the way into the heavier grass stand. Yep.
Thank you.
You're very welcome. Good question.
Thank you. And then on to kind of follow up on that, you said reach out to professionals, and who would be the professionals in a community that you could reach out to?
Yeah, I would always start in this case with the soil technicians with Soil and Water Conservation Service. They're the ones who actually do waterway design, lay things out and give you the specifications for how they would be shaped and what grass species to use. The contractors who do the work would be another good expert to talk to, especially if they've been at it for many years. They probably know those specs about as well as the people who write them after years and years of doing waterway construction. So those two groups of people would be my first choices to go to. You could also contact folks like me in the Extension Service, the agronomists and the ag engineers with ISU Extension and Outreach. We know enough to answer the simple questions and steer you to the experts for the tough questions.
Okay, perfect. Any other questions? Quickly, Sean, if people have more questions after this is done, how can they reach out to you to ask their questions?
Yeah, you can contact me either directly. I'll give you my cell phone number is 712-250-0135. Or you can contact any county extension office, and the helpful folks there will put you in touch with whichever field specialist they think would have the right answer for you. So it's one of the nice parts in extension is you can always go to your local extension office and they have all the contact information for the other folks around the state or on campus.
All right. Well, Sean, thank you so much for joining me today, and we appreciate you taking the time to talk a little bit about waterways and erosion. Next week, we'll be back with Aaron Soigling. He's our extension specialist for agronomy. He's going to be talking about spring planting, which is a very timely topic, maybe not on these snowy mornings, but hopefully by next Friday, it'll be a little less snowy, and we'll be turning our attention back to spring planting. So thanks again, and we'll see you next week.